Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In this video tutorial, we will continue on our journey using the TerraClimate Dataset or data product. So in the previous video tutorial, we basically just started our journey into that product or that data set, and we simply just developed two images, scaled medium images for maximum temperature images for our 2 decades. We plotted those two images and visually compared the two, etc, etc. So in this video tutorial that I want to do is to play around a little bit with the statistic, the reducer statistic, in terms of generating a single image from a, let's say, a decade image or a number of images. So I want to have a look and see if there's any significant differences if we play around with the statistics. So I'm gonna, so we left off at this particular video. Remember, we had two images similar to that, which was a scaled, remember the scaling of our images, and in temperatures, whether it's maximum or minimum, we have to scale it by 0.1. So remember that, etc, etc. So we generated those scaling images for 1960 to 1970, for that 10 years, a medium image, etc. So what I want to do now, and obviously we compared the two images. We compared the two images, and we used the inspector to see or to understand what has happened to maximum temperatures at a specific location over these two periods. So what I want to do in this particular video tutorial is play around with this statistic, the medium statistic, and see what the differences is, and where the median is the optimum or the better reducer to use or not. So what I'm going to do is I'm going to basically we're going to generate a mean, median, mode, maximum, minimum. So let's look at that 5 reducers. Let's look at that 5 reducers. So I'm going to generate 5 images, and each of those images will have the same date, same clip, same scale, same everything, except the reducer. So, and then we'll see what that looks. So let's generate a image, and to make it so that we can apply all of, let's include the whole time series or the whole time frame. So we're going to go 2022, etc, etc. So we're going to generate okay, so we do that one there. Okay, so that gives us the whole one. So let's change that to call it data set per se. So our data set, and then we're going to obviously use a data set, the scaling to that data set. So we're going to say it's data set scaled. Okay, so we call it the scaled data set, etc. Now what we're going to do is we're going to generate 5 of these statistics. So we're going to, let's call it a mean. So that will be using our scale data set, and we apply median to it. Okay, so let's then copy this and we generate the rest. So we're going to use that one. Then we're going to generate a mean. Okay, let's use this a median. Let's start with the mean first. So that will be a mean. That will be a median. And then let's paste a couple of them. That will be a sum. That will be a max. That will be a minimum. So let's have a look and see. So that will be a max, a sum. Call it sum. Sum. So let's call it sum. And that will be a max. Let's call that a max. let's call this a mode. See if there's a mode, the one that occurs the most. So these statistics are the same as the statistics you lose in any statistics course. So mean is the one, the average, median is the one in the middle, sum, add them all, so that will be a massive number. Maximum is the image where most has the highest temperatures. Mode, okay, so sorry, we have to have a min one there. Let's do that. A min as well. Min, and then let's see if we can do. Yeah, so let's first of all do those ones. Our visualization parameters, obviously that's going to be all over the place now. So let's make it, yeah, so let's leave it, obviously someone will be all over the place. Okay, so let's leave it there, and then obviously we're going to have to add all these ones to our layer. So let's do mean, mean, so that would be mean. Now you simply just copy and paste, and we're going to do median, sum, max, min, mode, I think. Let's have a look and see. Median, yeah, so let's do median, let's call it median. Then we're going to look at sum, so that's going to be sum. Then we had max, so we call that max. Oopsie. And then we're going to have minimum, and then we call this min, and we're going to call this mode, and it will be mode. Okay, so let's have a look and see. Let's run and see what happens. There's nothing in the console so far that indicates there's problems. If there are problems, there will be a big red thing here that says problem. So we generate 1, 2, 3, 4, 5, 6, 7 images now. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 images. 3, 4, 5, 6 images. Yeah, 1, 2, 3, 4, 5, 6 images. And that will be those reducers for the entire range of images in this image collection of TerraClimate, and we're looking at maximum temperatures. Remember, maximum temperatures are plus minus around 12 o'clock during the day. So the month will be obviously an average one of all the daily temperatures, the 31 daily temperatures. So the monthly statistic or maximum temperature is already an average. So just bear that in mind. So let's make it a bit bigger, and let's wait for the statistic to kick in, to work. Okay. We're going to do a couple others more. Remember, yeah, it's taking a bit of time because it's running through how many images there is 62 years, and 62 times 12, 600 to 700 odd, as I said, almost 800 images, 700 odd images. So that's now applying those statistics to about 700 images, 750 images. And remember, each image will first be scaled by this factor, and then obviously it will apply those reducers to generate a singular image. So let's give it a bit of time. Yeah, so let's give it a bit of time. Let's see what happens. Let me pause for now, and once it is all the images are up and running, I will continue with the video. So let's quickly pause for now, and then we'll continue. Okay, we're back. The images are loaded, but while I was waiting for the images to load, I also added 3 more reducers. Now, as I said, these 3 are our typical reducers, or in statistics, what we call the mode of centrality or centrality statistics, mean, median, mode, and those sort of statistics. But I also wanted to calculate the standard deviation, skewness, and kurtosis of these of this image collection. So you can do that using this code, and specifically using your reducer function within Earth Engine. Now, you don't simply just change, let's say, the mode to standard deviation. That's not going to work. So for mean, median, and this code is perfect. It works like a charm, no problem at all. However, for standard deviation, kurtosis, skewness, there's a covariance, product, on all of those other reducers, you actually should use the reducer function within Earth Engine, which looks like this. So you have your data set, and where you would just have simply just dot mode brackets, you have reducer, open bracket, Earth Engine, the function, the reducer, and then standard deviation, open and close brackets, and close brackets for the formula set. So I've included these three reducers as well. Okay, so these are reducers, although we don't say they are reducer, they are reducing. And I've also quickly calculated the number of images. So if I go into images, you'll see there's 756 images. Okay, and there they're all listed. Okay, so there's a whole lot of images in this image collection. As I said, 756 images listed, individual images. Okay, so what we're doing is we're taking all of that 756 and we're applying the scale of 0.1, and then we're reducing this 756 images to a single image using these reducers, which is mean, median, sum, max, min, mode, and then also these reducers, or these statistics, what we call skewness or dispersion statistics. Remember, this is in general terms what we call measures of centrality, and this is what we call measures of disbursements. So they are, reducers, but indicating either dispersion or centrality. Okay, so yeah, and then obviously we applying our visualization and our color palette, our color patterns, and then we obviously add all of them. Okay, so we add the mean, median, sum, max, mode, mean, and then we're also adding the standard deviation, skewness, and kurtosis. Okay, so that's quite a bit of reducing. So let's have a look and see what the results look like. Okay, so let me put it up. Let's close all the layers, and let's start from the mean. Okay, so there's the mean statistics. Let's make it a little bit bigger. Okay, there's the mean statistic, and there's the median. Okay, so you can see there's some difference in the two. Come on, now it's struggling to load again. It's because it's such a big region of interest and so many images that it's struggling to load again. Nonetheless, let's quickly, while this is loading, let's use a inspector. Okay, so let's make it a bit. Okay, so let's calculate this particular. Remember, this was particularly hot area, so let's use that. So while it's loading, let's calculate the statistics. So the mean maximum temperature for this area or that specific location is 27.39 degrees. Remember, that's now the mean monthly scaled maximum temperature from 1960 to 2022. So that is, of all that 756 images, this is the mean maximum temperature for that area. Okay, so that's 27. So that the medium is 28. So you can see it's a little bit higher. So this already indicates a skewness towards the right, to the upper part. If the mean is less than the median, it indicates that there's bias towards the higher end of maximum temperatures. Look at the sum. Okay, the sum is going to be a crazy number. So that's 756 times the maximum temperatures, or adding all that 756 maximum temperatures. That's 20,000. Okay, so you actually have to divide it by 76 and you should get to 27. Let's have a look. The maximum is 35, so that doesn't say which year, unfortunately, but the maximum temperature in this 1962-2022 was 35 maximum month. Minimum was 17, so very hot, very cold. The mode, it's got a mode, which is 31, so that's the value that occurs the most. Again, you have the mean, the lowest, the median, higher, and the mode, the higher. So that indicates negative skewness or bias towards the maximum higher temperatures. Okay, now we get to standard deviation is 4.75. So that's quite a bit. There we go, skewness minus 0.15, so that is negatively skewed. So again, that indicates small amount of small temperatures or low temperatures and a high amount of high temperatures. So it's not a normal distribution, it's a skewed distribution, which is a negative distribution. And then there's kurtosis, which is minus, so that's negative kurtosis, so it's a very flat distribution. Okay, so that already gives you some indication, just as normal statistics, on the nature of maximum temperatures at that. Remember, this is now for that specific location. It's not for our region of interest, it's only for that specific location. Okay. So yeah, so that gives you a nice statistical analysis of maximum temperatures for that specific location. Okay, so let's see all of these ones have loaded. Let's quickly have a look again and see what it looks like. So there's my mean, there's my median. You can see it's not a lot of difference between the two. In fact, it's hardly noticeable. And that is, again, you can see that's how similar mean and median is. However, median is more than the mean. Some, obviously, it's going to just be one red thing because it's so high, so that makes sense. Maximum temperatures, you can see that as well. There's a minimum temperatures. You can see the difference between minimum and max. Obviously, if we subtract these two, we will get the range. Okay, so you can do that as well. There's no reducer, but you can just do a calculation to calculate the range for each, which will indicate the difference between the maximum temperature and the minimum temperature. There's the mode. Okay, so let's take that out. So that's the mode. Interesting. There's a standard deviation. Obviously, standard deviation will be one value. Okay, and there's the skewness and the kurtosis. Now, the standard deviation, skewness, kurtosis in terms of the image is not really any significance. So in those ones, you actually look at the value as determined by the inspector rather than the image itself. The image itself, the value means nothing or very little, and you can see there, because remember, our visualization parameters are minus 30 to 30, and you can see the visualization parameters for standard deviation skewness is very small, so you have to almost create a new visualization parameter for these three rather than using these absolute numbers. It's just way too big, so it makes sense that the numbers are not going to look that great. Okay, so yeah, so we've reduced ours. Remember, there was 756 elements in this image collection. So we've used these statistical reducers to reduce the number of images from 756 to a singular image within this image collection. And each of these reducers generates a different image and a different statistic, which individually may not be very useful, but as a collective, they actually gives an interesting picture or analysis of that specific location. So let's have a look at generate another location. Okay, so we're going to inspector. Remember, well, let's look at this. This was the mountainous area. So let's look at that area. Let's make it a little bit bigger. Let's take this off. Let's go to median. I would still, if I look at this, use the median because it is, you know, see, look, there's the mean 19.8 and 20. So in this case, whether you use the mean and the median are neither here neither there. They are very similar. Obviously, I won't use the sum. Look at the maximum temperatures. That's also not, and the minimum temperature is good in terms of the range. Mode, you can see the mode is 24. It's again, it indicates negative skewness. With those three, you can see there negative skewness, negative kurtosis. So it's a flattish distribution. It's skewed to the right-hand side or to the upper temperatures, etc., etc. So that's seems like most of the locations. Well, we've done two. Let's do a third one, and then let's take that as a representative sample of the whole area. So similar, 27. Where's the mode? In this case, the mode is 17. Okay, so in this case, the mode is actually less than the mean and the median. So let's have a look and see. But the skewness and kurtosis are still negative. So it's still, you can see the mode there, 17. Yeah, so it's still negatively skewed, flattish distribution. Okay, so that's interesting by itself. As I said, one can play around with these reducers. You can have a look and see if there's any other reducers that you want to. Obviously, one can now generate a coefficient of variance, which is simply the standard deviation divided by the mean. So you can generate a standard deviation for each and every location, and also a range, just using your normal calculations within the code editor. And obviously we can also so let's stick with that. Okay, so let's quickly do, remember we can do let's do something different on the same vein, but let's do something different. Let's have a look and see if we have wind speed. I like wind speed, so let's quickly work at wind speed. Wind speed is 0.01, so we're going to have to change that to 0.01. Remember, our scaling factor, wind speed, is Vs. So let's just change that to Vs. Now you won't have a negative wind speed, so the minimum wind speed would be 0. What would be the maximum wind speed? So let's quickly just there. The maximum wind speed would be this one, 29 meters per second. So let's keep it at 30 meters. So remember, this is now meters per second, not Celsius. Okay, so let's make sure we've changed it to wind speed. All of it is the same. We've changed the scaling factor, and we have adjusted the minimum maximum in our visualization parameters. So remember those three. Okay, so now we just remember, save before we run, because maybe it will time out and then we've got problems. So okay, so it's, remember, see, it's when it's unlit, then it means it's saved. Okay, so let's run it. So now it must probably, again, I'm going to take a bit of time. Let's take those two off. It's most probably going to take a time. So let's use our inspector again, and let's look at this area here. Let's look at wind speed. See what's the statistical properties of wind speed in this particular area or location within my region of interest. So there's the mean wind speed, 2.9 meters per second. Okay, the sum, yeah, as I said, the sum. Okay, let's just quickly have a look and see again. Number of images, 756. Okay, how do I determine it? I just use print and the name of what I want to print and the variable that I'm going to print. My mean is 2.94. My median is 2.91, so that's on the left hand side. My maximum is 4.8. My minimum is 114. Remember, some we actually could delete. Mode is 2.3. So that's interesting in that we now go in the opposite direction, more to a positive distribution, because the mean is to the right of the median, and the median is to the right of the mode. And you see there, okay, there we go, positive skewness. So that means there's a lot of values on the lower level of wind speed and fewer to the higher levels of wind speed. So it's more often low wind speed than high speed. Kurtosis is still very flat, and standard deviation is fairly little, so that means there's not a lot of variance or volatility in wind speed. Wind speed is mostly on the lower levels, and it's a really flat distribution. So that's interesting, which is basically just the opposite of maximum temperatures. So that's fascinating by itself. You can see the color patterns, which is blue. Let's quickly see whether it's still struggling to download, so it's most probably not going to download within the next couple of minutes. But I think you get the idea of what is possible. Okay, so that is going to be the maximum ones. Let's take that out. The sum. Because the sum would obviously be red because it will just add all the minimum temperatures. So let's exclude the sum. But yeah, it's going to still take a bit of time. Now the visualization parameters doesn't really work. So changing the parameters of visualization using the visualization parameters are not really effective because of this is a calculated, a reduced image. So it's not an individual image which you can use the visualization parameters. If it was an individual image, you can use the individual, but because it's a reduced image, yeah, it's not going to really work. So that's interesting enough. Now that is wind speed, as I said, for that specific location. Let's have a look at it here. We do that specific location, which is around here. Remember, it will give you the location, and it will tell you the point. It will tell you the long and the lat, and yeah, so that's what it will tell you. And okay, so there, so this is now interestingly. Now this is just the opposite. You can see. Where's the mode? This is just the opposite. This is so because this is a coastal town. So coastal would normally have much higher winds and much more volatility in the winds than the inland. So yeah, that makes a lot of sense. Yeah, quite interesting. Yeah, this is actually quite nice. So you can do it in terms of finding positive skewnesses and negative skewnesses, etc., etc. So yeah, interesting stuff. So that's working with reducers within a image collection and reducing the images to single or images using those reducers and the codes for those reducers and displaying them and using the inspector. Yeah, I think that was quite interesting information that we gathered. Yeah, fascinating stuff. Okay, thanks for joining me. Okay, there comes the images are slowly but surely coming in. Let's have a look and see. There's the mode, minimum, maximum, median, and mean. You can see the median and mean are very similar. Obviously the sum is going to be just red. There's the maximum. It's struggling still to load the maximum. Minimum, it's struggling to load again. It's slowly but surely, but I think you can get the picture, play around with it. Yeah, interesting stuff. Okay, remember to save, run, use the inspector, etc. And obviously all of these layers you can export. I haven't included export options here, but you will be able to export all of these images for, let's say, to work with it in QGIS, whatever the case might be. Okay, thanks. Yeah, no, great stuff. Well, yeah, nice quick little video, interesting stuff, working with reducers. Fascinating. And stay tuned, more to come. Please remember to like and subscribe and to share the video. The more the merrier, as they say. How do they say? I always say to my kids, caring is sharing is caring. So remember, sharing is caring. Okay, I'll see you on the other side.